All right, guys, today we're going to look at page 189 and 190 where we're writing whole numbers as a fraction. And I know some of you might be thinking, what fractions are parts of a whole? How can a whole number be a fraction? Well, just like if you have a puzzle and you get all of the pieces and put them back together, you make the whole puzzle. And you can have more than one puzzle. So you can think of each of the pieces like a fractional amount. So in our example, Miss Clark cut two same-size pieces of colored paper into sixths. So this was a whole sheet of paper, and this was a whole sheet of paper. She cut each of those into sixths to make strips for paper chains. How many strips did she make? Well, one whole sheet of paper gave her 6 1/6 pieces, and two holes gave her 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 1/6 pieces. So altogether, two whole pieces of construction paper gave her 12 sixths. So 12 sixths is equal to 2. Now we're going to look at this example. They've given us 3 holes. I know that these are wholes because each part is labeled as 1/3. And 1/3, 2/3, 3/3. 3/3 makes a whole. So number 1 says 1 whole equals blank thirds. Well, kind of just told you that one, didn't I? So 1/3 is equal to, 1 whole is equal to 1/3, 2/3, 3/3. That doesn't look very pretty. Let's make this a little bit thinner and maybe change our color. That's a little better. All right, question number 2, 2 holes. So that means this one and this one. Let's count how many thirds we have. 1 1/3, 2 1/3, 3/3, 4/3, 5/3, 6/3. So 2 holes is the same thing as 6/3. Now for 3/3, I can use what I remember. I knew that 2 holes are 6/3. So let's count on from there. 6/3 here, 7/3, 8/3, 9/3. Maybe some of you are catching on to this pattern. Every time we want to add another whole, we just add 3/3 because 3/3 make one whole. So if we want to get up to 4 wholes, we'll need 3 more 1/3 strips. So 9 1/3 strips plus 3 more 1/3 strips would give us 4 holes. So that would be 9, 10, 11, 12 thirds. Let's go flip our pages to page 190. Now we're going to use a number line to find equivalent fractions. And it may help before you even come down here. I would go ahead and let's continue labeling our information up here. So here we have from 0 to 1, we have 1, 2, 3, 4 sections. So each one of these sections is 1/4. So you get up here to 1 whole and you've got 4/4, 5/4. So right here is going to be 6/4. And then this tick mark is going to be 7/4. And then this tick mark is going to be 8/4. And then we're going to come over here. We're at 9/4. That's what this one's going to be. 10/4. Okay, let's move that one over just a tad so we have enough room for this one. Now we have 11/4. And finally, 12/4. Now let's see if that helps us answer our questions. 1 whole equals blank fourths. Well, I see on my number line, here's 1 whole. And right beneath that, I can see it takes 4/4 to equal 1 whole. Question number 6, 2 holes equals blank fourths. Well, I come here to 2 holes, and I can see that that lines up with 8/4. And down Here to number 7, it says 3 wholes equals how many fourths? Well, we did that on here. 3 wholes is equal to 12 fourths. Oh, and now they're trying to trick us, but we're too smart for this. 0 equals how many fourths? Well, I don't have it written over here, but you guys, we've done this in class. 0 fourths is the same thing as 0. That's when you don't have any fourths. Now we're going to use this number line to answer problems 9 through 11. So the first thing I have to do is figure out what this number line is broken into. So to do that, we're going to count how many spaces we have. Remember, we're not counting all the tick marks, just how many pieces it's broken into or how many jumps I can make. So there's 1, 2, 3, 4, 5, 6, 7, 8. So each hole is broken into 8 parts. So this is broken into eighths. 1 whole is equal to how many eighths? Well, let's count. 0 eighths, 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, 8 eighths. So 1 whole is equal to 8 eighths. 16 eighths is equal to how many wholes? Well, we know that this was 8 eighths. Let's go ahead and just write it on here so that we don't forget that. So let's use that to count on from until we can get to 16. So this is 8 eighths right here. So then we'd go 9 eighths, 10 eighths, 11 eighths, 12 eighths, 13 eighths, 14 eighths, 15 eighths, 16 eighths. So this tick mark right here takes us to 16 eighths. So 16 eighths is equal to 2 wholes. And now it asks us 3 is equal to how many eighths? So I need to keep going. We've got 16 eighths right here, so then 17 eighths, 18 eighths, 19 eighths, 20 eighths, 21 eighths, 22 eighths, 23 eighths, and finally 24 eighths. 8, 16, 24. That kind of seems like a pattern. I wonder if any of y'all noticed that. I bet you did because you're so smart. I know if we were in class, y'all would be raising your hand saying, Miss Clemons, those numbers are in the 4 song. All right, moving down to question number 12. Use the model below to write a fraction equivalent to 3. Well, I'm looking at three whole squares, and each square has been broken into fourths. So I'm going to do fourths. And now I'm going to count and see how many fourths I have here. 1, 2, 3, 4 fourths, 5, 6, 7, 8 fourths, 9, 10, 11, 12 fourths. So 12 fourths is equal or equivalent to 3. Last question. Draw a model to show 2 wholes equals 8 fourths. So first I need to draw 2 wholes. Let's do circles. We haven't done circles in a while. And I want some purple circles. Purple hurricane circles. There's 1 whole circle, 2 whole circles. And it was saying 2 wholes. So now I'm going to break that into fourths because my denominator is fourths. Okay, that's in fourths. And now this hole's in fourths. So I've just drawn a model to show that 2 wholes equals 8 fourths. And I'm done. Have a great day.